Here's example 1 of evaluating something using sum and difference formulas. So in this example we want to evaluate the sine of 105 degrees. So the idea here is to express 105 degrees as the sum or the difference of two special angles on the unit circle. So we know that 105 degrees is 60 degrees plus 45 degrees. Okay, that's one way of doing this. So let's go ahead and continue with that. So sine of 105 degrees equals the sine of 60 degrees plus 45 degrees. Okay. So now we're just going to use the sum formula that we established in an earlier video. So if you want to copy this worksheet, it's not really a worksheet I guess, just a formula sheet with all these trig formulas on it. There's a link in the video description. You can click that link, open this up, print it out, and follow along if you like. So here is sine of one angle plus another angle. So using the formula on our sheet here that we established in an earlier video, this is going to be our angle alpha. And then this right here is our angle beta. Okay, so we have sine of alpha plus beta, so this is going to be sine of alpha, which is 60 degrees, times the cosine of beta, and beta is 45 degrees, and then plus cosine of alpha, and again alpha is 60 degrees, times the sine of beta, and beta is 45 degrees. Okay, so from here it really just comes down to knowing the unit circle. So sine of 60 degrees, that is the square root of 3 divided by 2. Cosine of 45 degrees, that's root 2 over 2, or 1 over root 2 if you don't want to rationalize the denominator. And then plus cosine of 60 degrees, that's 1/2. And then sine of 45 degrees, that's the same thing as the cosine of 45 degrees, actually it's root 2 over 2. Okay. So we can do just a little bit better than that. So this is going to be square root of 3 times square root of 2, that's square root of 6. So remember square root of, if you have square root of m times square root of n, in general that's the same thing as square root of m times n. So when you multiply square roots, you can squish them together under one square root. Okay, that's not true for addition. Okay, so be very careful about that. That's not true for addition, but it is true for multiplication like that. Okay, so be careful. So root 3 over 2 times root 2 over 2, we can squish that all together into root 6 over 4. And then what's going on here? 1 times root 2 is root 2, 2 times 2 is 4, so this is root 2 over 4. Common denominator, we already have it, it's 4, that's great. So this is just square root of 6 plus square root of 2, all divided by 4. Hey, and again, be careful, you cannot combine, root 6 and root 2 cannot be combined, so be very careful about that. You can only combine if you're multiplying like root 3 times root 2. You can combine like that, but one square root plus another square root can't really do anything with that. Okay, so anyway, that's the final answer here, root 6 plus root 2 all divided by 4. Kind of goofy answer, but that is what it is. And it's just a relatively straightforward application of sum and difference formulas and using them to evaluate a trig expression here. Okay, so that's example 1. And again, the answer is root 6 plus root 2 all divided by 4.